In this pencast, we are asked to recognize and factor a difference of perfect squares. The first thing we need to go over is the general form of what a perfect square is. And that form is, if we're given a squared minus b squared, we can factor it immediately into a plus b times a minus b. And just to prove that that is true, if we do FOIL, which is first, outer, inner, last, we see that we have a times a plus a times negative b plus b times a plus b times negative b, which gives us a squared plus negative ab plus ab minus b squared, which gives us a squared minus b squared. So we see that it does, in fact, they do equal each other. And this is just a technique you're going to want to know because it will make factoring a lot easier to recognize the perfect squares. If we're going to look at it as far as a quadratic, we would say that it's ax squared plus 0x plus c. So the linear term is just 0. Let's do a couple examples. First, we're asked to factor 4x squared minus 36. So we see or recognize that this is going to be a perfect square because if you take the constants of each of the terms, then their square root should be a rational number. So 4, square root of 4 is 2, which is a rational number, and 36, the square root of 36 is 6, which is also a rational number. That being said, we can then define our terms. We know that a in this case is 4x, a squared is 4x squared, and b squared is 36, which means a is the square root of that, so 2x, and b is the square root of 36, which is 6, which means if we put this into our formula, we can see that 4x squared minus 36 equals a, which is 2x, plus b, which is 6, times a again, which is 2x, minus b, which is 6. So 2x plus 6, 2x minus 6. And that is our final answer for this one. Let's look at x to the fourth minus 1. We know that if we don't have a number in front of a variable, that number is automatically 1. And the square root of 1 is 1, which is a rational number. And again, we have 1 over here, so again, we have a rational number, which means that a squared is x to the fourth, and b squared is 1. So we can follow the formula. We know that the square root of a squared is a, and the square root of x to the fourth is x squared. And the square root of b squared is b, square root of 1 is 1. So if we plug that into our formula, we have a plus b times a minus b. And again, we have our final answer. So the thing to remember with this is just to look for square root of the constants. And if those square roots give you a rational number and the exponent of your terms are even, then you can use perfect squares. If you have roots that give you non-rational numbers or odd exponents, you can't use the difference of perfect squares.